in this problem, we're told if the switch opens at t equals 0, find the output voltage V0 of t for t greater than 0. We're going to use our problem solving strategies, one on S-domain circuits and one on loop analysis. We'll actually solve this circuit using loop analysis. So if we look at our problem solving strategy for the S-domain circuits, the first step is we draw the circuit at t equals 0 minus. We assume steady state, so the inductor is replaced by a short. Now what we want to do is we want to solve for the initial condition, or the current flowing through this inductor the moment before the switch opens. So at t equals 0, this switch opens. So at t equals 0 minus, here's our circuit. So there's our circuit. And what we're going to do is we'll solve this using loop analysis. Here's I1, here's I2. So if we look at the left loop or mesh over here, we'll have 4I1 minus 2I2 equal to 16. So this is for the left. For the right, we'll have minus 2I1 plus 4I2 equal to minus 4. And now we really need I2. So solving for I2 yields 2 equals 4/3 of an amp, and that's IL of 0. So now we've got the initial condition. So now we're ready to go to the next step, which is to draw the S-domain circuit. Okay, here's our S-domain circuit. You can see what we've done with the resistance. Here's the inductance. Here's V0 of S is across here. Now here's our initial condition for the inductor is handled by placing a voltage source IL0. The inductance was 2 henries. IL of 0 we just calculated to be 4/3 of an amp. So now let's define a current IL in that direction, and what we'll do is once we find IL, we'll know V0 of S is 2 IL of S. So now we'll just start in here and just do our analysis. So applying KVL around that loop, we'll have 4 IL of S plus 2S IL of S minus 8/3 minus 12 over S is equal to 0. So now it becomes a matter of just working with algebra. So we have 2S plus 4 times IL is equal to 12 over S plus 8/3. Now let's factor out a 2. So we have S plus 2 times IL of S is equal to 6 over S plus 4/3. So now IL of S then is 6 over S times S plus 2 plus 4/3 over S plus 2. Now then V0 we notice is 2 IL. So V0 then is 12 over S times S plus 2 plus 8/3 over S plus 2. So now we just need to go in and do a partial fraction expansion. So if we look at our step 4, where we're going to go through now and perform the inverse, we have 12 over S times S plus 2 plus 8/3 over S plus 2. So we can write V0 then is V0 of S is K1 over S plus K2 over S plus 2 plus 8/3 over S plus 2. So then K1 we multiply through by S, S equals 0. So that gives us 6. And then for K2, we multiply through by S plus 2 and let S equal minus 2. So we have 12 over minus 2, or minus 6. So now V0 of S is 6 over S plus minus 6 over S plus 2 plus 8/3 over S plus 2. And we can combine these two terms together, so we have 6 over S. We have minus 6, which is minus 18/3 plus 8/3, so this becomes minus 10/3 over S plus 2. So then V0 of t then is 6 minus 10/3 e to the minus 2t u of t volts.